Welcome along, everybody, to this seminar. I'm going to be just giving a short introduction, mainly just talking a little bit about this season and how it might have impacted on what diseases we're actually seeing in crops at the moment. So I don't think I'm telling anybody anything that they don't already know, that this has been a pretty wet year in WA. And in fact, we're probably looking at decile 9 rainfall or even higher for many regions of WA. And associated with that, we know that the start of the season was pretty good, and so crops got away well. And we're probably seeing, nice dense crops with thick canopies being established by this time of the year. Just to give you an indication of that, these are the seasonal rainfall records for four places across the wheat belt, and obviously we're looking at Coginura up down in the south, Lake Grace, Killarney in the sort of northeast, and then Eneabba in the northwest. And what you can see is that bluey purpley bar line is the 2021 rainfall, and those greeny yellow coloured bars are the 90, 50, and 10% deciles. And pretty much you can see that at all of those locations 5 days ago, we were above that 90th percentile in terms of seasonal rainfall. And the other thing I think you can see is that the impact of that July rainfall, I think in many areas, July had probably more than 20 wet days, and more than 2/3 of the days in the month were wet, which certainly has generated ideal conditions for disease development. So what we know as a result of that rainfall is that grain yield potential is high, that there's plenty of stored soil moisture, and I think the expectations for crops across WA is high. What we do know is that obviously foliar diseases proliferate under these conditions. So these frequent wet days are ideal for many of the foliar fungal diseases that we regularly see. What does this mean in terms of going into the spring? As things warm up, often we see that diseases move more rapidly, and certainly an interaction, usually in spring, it's an interaction between the disease that's present in the crop and the rain days that are likely to occur. The outlook is probably for a median or below median spring. Maybe that might reduce some of the pressure on crops, but certainly there is a level of disease in crops across a number of regions. What does that mean? Well, that means that obviously fungicide use to now and expectation for use is high. And that's certainly relevant for our current discussion. The other component of this and the timeliness of this presentation is, apart maybe from some of the more northern crops, a lot of our crops are now approaching that critical decision-making point of that flag leaf or booting stage, where we are making that decision about whether or not a fungicide now would be useful. Just very quickly, what does this mean in terms of diseases? I think it's fair to say that pretty much we here at DPIRD and generally through discussions that I've seen in social media, pretty much every disease that you might recognise has been seen in crops. Now, in terms of barley, obviously there's net blotches around, but I've just recently heard some concerning comments about higher levels of net blotch in some crops, and that will need monitoring. Powdery mildew in barley is certainly making a bit of a comeback, and certainly in result of some of that changing of pathotype and the virulence to MLLA or the Rosalind virulence is meaning that Rosalind and to a lesser degree varieties like Maximus and Spartacus maybe are being impacted more by powdery mildew. In wheat, I think we've just recently had several reports of powdery mildew in wheat, both from the south coast, but up through the central region, and certainly that is something that we will need to be monitoring for quite regularly. I won't go through the rest of those diseases particularly, except for to note that I've put rusts here for oats, and And we know that there's many reports of wild oats hosting quite a degree of leaf and stem rust. And so that's certainly a risk for oat cropping. And probably the other disease that I will mention is the fact that both canola and lupins and other pulses, in fact, have had significant reports of sclerotinia, and certainly that is a disease of concern. Of note is, of course, that many of the crops in the more northern parts of the state have probably passed the point at which we're able to, according to label regulations, apply fungicides. Anyway, that's a very brief introduction to where we're at this season, and I'll pass on to Fran for some of the more gutsy fungicide resistance information.
Geoff, for the good introduction. It was really nice to see that, yeah, we've got a lot of rain, but also that means that we've got lots of diseases. And with diseases, obviously, we've got plenty of fungicide use. I wanted to start by giving you a very quick overview of what's the situation in Australia in terms of fungicide resistance. Many of you probably have seen this slide many times before, but you probably can see that there are a few changes there. So we now have fungicide resistance in Septoria triticide to group 11 chemicals, so strulurins. That wasn't there in our table before. That's a new introduction. Today, we're going to be targeting a few Western Australian issues, right, diseases. So mainly we're going to be talking about net blotches, right? And at the end of my slides, I'm going to be talking a little bit about wheat powdery mildew, okay, as well. So just to remind you very quickly, in terms of the different classification that we follow in terms of the different levels of fungicide resistance or sensitivity. So we talk about sensitive when our fungicides still work, right, as usual. Reduced sensitivity when some fungicides are showing a small decline in the efficacy, right? So you can actually see that they don't work as they were working in previous seasons, but still you can control the disease, right, to a certain level. And then we've got resistance. Resistance, basically, we refer to practical resistance here, all right? So the fungicide is not capable of controlling the disease in the field anymore. So some of you probably have been participating in a project that we are running at the moment. It's the barley cohort project. So this project has been extremely successful at providing a really nice snapshot of the situation in Western Australia in terms of fungicide resistance to DMIs in net blotches. So I've got here an update on the situation for net 4 net blotch and group 3 fungicides in 2020. Obviously, we rely on the data that was collected in 2020. We haven't received the samples for 2021 yet. I've got there on the right-hand side the number of samples that were collected or received, 115 samples. 17 of them were positive for net 4 net blotch, and the analysis of them produced that map that you can see there. So pink means resistance, blue means reduced sensitivity, and green means sensitive. As you can see, there are not many samples, but there's an important presence of reduced sensitivity and resistance in the population of net blotch that was analyzed. Now, I guess that probably this other map, spot for net blotch, same fungicide, group of chemicals, group 3, is a bit more revealing and concerning. So we obviously have more samples to play with. So 79 out of the 115. For those running, numbers in a calculator, yeah, there's a number of samples that didn't produce fungi that we could actually analyze, right? That's quite normal, okay? Some samples were received with no disease, and others, well, unfortunately, we couldn't retrieve the fungus. As you can see, that we ran plenty of analysis here, 475 different cultures were analyzed, and you see that there's a lot of pink around, all over the map. Okay, which is actually quite concerning. Reduced sensitivity is also important. There are plenty of blue dots, but we also have some sensitive population out there, which is good. Okay, so because obviously at some point all those populations are going to be crossing, right? And there's a chance that, you know, our sensitive populations can help in diluting the resistant trait in the offspring. Okay. Basically, in this slide, I'm just summarizing a couple of different things. We wanted to see if the basically the rotation that the different paddocks from where we receive samples for the barley cohort project had something to do, was related in some, you know, somehow with the resistance levels that we were detecting. So I have circled here a few region in each of the maps. It's the same region, and probably I will go through the legend again. So green means that the paddocks had barley on 2019 and 2020. Yellow means that the paddocks had canola in 2019 and barley in 2020. Red means that the paddocks had wheat in 2019 and barley in 2020. Okay, obviously these are barley samples, so 2020 was barley. Okay, and so on. All right. So interestingly enough, so we've got this region here where primarily there was barley on barley. Okay, in 2019 and 2020, and as you can see on the right hand side, these maps that I've got here with the resistance in net 4 net blotch and spot 4 net blotch. So it's quite interesting that the majority or a high proportion of the pink dots resistance, right, were actually located within this region. Okay, so for net form, virtually all the points, all the pink points were here. The resistant samples were identified here. And for spot 4 net blotch, you can see that the majority of the points detected were actually pink, right? So it was also reduced sensitivity and just a single dot that was sensitive, okay? And if you have a look at the south, so you can see that the populations are a bit more heterogeneous. So with some sensitives and plenty of reduced sensitives as well, okay? So I guess that the important message here is that the barley and barley rotation, obviously, you know, it can have, you know, economic benefits, and in some regions, you know, it's been seen as the crop that it has to be grown for particular reasons, soil conditions, whatever. But obviously, we're paying a toll, right? So we've got a higher disease level, and the selection pressure that we are applying is continuous. We're not breaking the selection pressure, right? So we are just selecting for net blotch resistance every year. Just quickly, this is a slide that I have been showing around quite a lot. So this is from the analysis, SDHI resistance analysis that we did on Curtin last year. Probably some of you will remember this. This variety, Spartacus, was showing high levels of spot 4 net blotch. So we were alerted by Dan Taylor from DKT Rural Agencies, and we went there, sampled, and basically came across SDHI resistance and reduced sensitivity mainly, right, in a few paddocks that we actually analyzed, right? So I'm showing here 5 paddocks, okay, and green, sorry, the color code is different here. Orange shows reduced sensitivity, okay. Red shows resistance. As you can see, is quite a small proportion, right? But reduced sensitivity is quite high. And blue indicates sensitive, okay? So this is something to take into account. I mean, it's just probably, you know, it's going to keep increasing, it's going to keep spreading, right? Due to the widespread use of certain chemistries, all right? But the reason why I was bringing this up, okay, and sorry, I've got here also this graph that shows the differences between different SDHIs. So not every SDHI works in the same way. So not every SDHI is affected, right, in the same way, but the different mutations that were found in these paddocks, okay? I've got here a few different ones. Probably you're familiar with Bixafen, which is in Aviator X Pro, and fluxaperoxide, which is in Sestiva. So these numbers here indicate how much resistant is a reduced sensitive genotype compared to the sensitive, how much resistant is a resistant genotype compared to the sensitive. So you can see that for Bixafen, the resistant population was 58 times more resistant than the natural wild type sensitive population. And for fluxaperoxide, that number was higher, 97 times, right, more resistant than the wild type population, okay? You've got two numbers here because obviously, you know, everything is always more complex than, you know, what we communicate. So there are different levels of reduced sensitivity. That's why there are two orange lines. Okay, so that basically means that there are different mutations providing a very similar level of resistance, right, compared to the wild type. Okay, but for the purpose of this talk, I think that it's just, you know, relevant to say that there are three categories: sensitive, reduced sensitive, and resistant. Now, the reason why I was saying I was bringing this up is because just recently, as in, you know, a week, we came across this detection here in the region of Namalab, right? This is a spot form blotch sample, although this sample was actually collected by Jayasena from DPIRD. He reported a co-infection between the form and spot form. So we were successful at isolating a spot form. Sometimes it's quite hard to isolate the two fungi. And this spot form isolate that we retrieved from the sample, it had a mutation that confers reduced sensitivity to SDHIs that was also present in the Canderdine area. Okay. Now, the very interesting thing about this sample is that not only contained a mutation that confers reduced sensitivity to SDHIs, it also contained a mutation that confers reduced sensitivity to DMIs. Okay. So obviously we're using the two chemistries together. So we end up selecting, you know, for double mutants more often than we would like to. Okay. Now, and this is my last slide, I promise. I think it's also important to take into account that we are not immune to all the problems that are actually, you know, arising in the East. They will happen here eventually. This is wheat powdery mildew. And I know that there's some wheat powdery mildew, you know, happening in Western Australia at the moment, and we use chemicals the same, you know, the same way just to control this disease. So I wanted to show you a very quick example of what happened in the Eastern States last year. This was a collaboration with Steven Simpendorfer from New South Wales DPI. Obviously, these days, although, you know, I have already said twice that I'm a caveman, I know that, you know, technology has its advantages. So normally now, we are alerted, you know, by social media. Okay, so this is how, you know, we came across this problem. So agronomists talking about the problem in the field. So the lack of control of wheat powdery mildew, right, by DMI chemicals, right? So this is basically a picture of one of the samples that we were sent. You can see, you know, that there's mildew pretty much everywhere, covering the heads. All right. So the samples, we organized on sampling around the region. So we basically took, we didn't take the samples directly, so the agronomists took the samples. So samples collected from New South Wales, right, and also across the border with Victoria. Okay, there were plenty of samples that were sent, right? And then we did some sensitivity analysis, or phenotypic analysis. This graph is just basically to illustrate the difference between sensitive and resistant. It's not to illustrate the difference between how, you know, two compounds perform. All right. So don't get caught into, oh, prothioconazole performs worse than tebuconazole. No, that's not the purpose of the graph. Okay, not the purpose of the analysis, certainly. Okay, so that clearly shows that sensitive strains, they've got a lower level of sensitivity, obviously, to two chemicals that we were using in this case, prothioconazole and tebuconazole, okay, compared to resistant strains. All right, Teb sitting here for sensitive, sitting here for resistant, right, and prothioconazole, you know, the same pattern. Again, look at the pattern. Don't get, you know, confused by the products. Okay, this is not an efficacy test. All right, this is a resistance test. Obviously, that led us to perform some genetic tests, okay, and we found something quite interesting. So virtually, pretty much everything that we analyzed contained a mutation that we have identified as a gateway mutation to fungicide resistance in DMI compounds. Its presence doesn't mean that you're going to have resistance, but is required for the emergence of other mutations. Obviously, there are other mutations there that we are still characterizing, okay? And that probably explains, you know, the difference in sensitivity between the sensitive and resistant strains. Now, what nobody actually was expecting is that there was also resistance to QI chemicals. And this is the reason, you know, I really want to bring this up today, okay? So at least in 3 of the samples, the frequency of imitation that confers total resistance to QIs was extremely high, okay, close to 100%, all right? And we couldn't come across a sample that didn't have at least, you know, a small frequency of that mutation on it, okay? So one of the problems, again, very susceptible varieties were used, okay? So the majority of the control was, you know, the heavy lifting was done by the chemicals, and we know what happens, you know, when we over rely, you know, on the chemistry. So resistance basically emerges. It's just part of nature. I guess that a small message right here, very brief, but very important around the management in this case. So we're not aware of this problem in Western Australia yet, okay? But we should be very, very concerned about it, and we should limit the number of QI treatments that go on controlling wheat parry mildew in this season and going forward. And I'm gonna basically stop here, and so Geoff will continue from here with management. So over to you, Geoff, and thank you very much for listening.
So look, very briefly, because I am aware that we've used a lot of people's time, I guess the Fran's maps have demonstrated that fungicide resistance isn't just a South Coast issue that, you know, possibly in the past we've been guilty of thinking, and it's something that we need to be aware of everywhere in terms of managing disease. And I guess how do we go about reducing the development of resistance, or the spread and the expression of resistance? And I guess the approach is we need to reduce the reliance on fungicide. So we need to think about all aspects of integrated disease management. We think about integrated disease management as a pyramid. The base of that pyramid is going to be the variety on which we're using, the susceptibility of that variety, the options, and if we have options to change variety, to choose varieties with better resistance or maybe reduced susceptibility to disease, that is the first point on which we can limit the impact of disease. Thanks, Bridget. And so look, just a very brief example. I won't spend a lot of time on this, and people have probably already seen this, but this is a trial that was done last year by DPIRD at the Muresk Institute, where we're just looking at growing 2 varieties of barley onto spot form infested stubble. So we're Maximus, which is a moderately susceptible to susceptible variety, and Spartacus, which is a susceptible to very susceptible variety. And we were just looking at how that alteration of variety susceptibility, how that impacted on disease progress and on yield impact of the disease. And I think the graph is fairly self-explanatory, that the yield impact of disease is far reduced in Maximus, that less susceptible variety, and that the impact of that disease, you know, in Spartacus was about 900 kilos, and in Maximus was about 250. And more importantly, I think, in line with what we're talking about, we can see that a single application of fungicide in Maximus retrieved retrieved the same amount of yield as a double spray approach or a double fungicide approach, which was not the case in Spartacus, which needed at least those 2 fungicides to retrieve yield. So there's certainly and we know in barley, in spot form net blotch, there are a number of, Maximus is not the only example of a number of varieties with improved resistance that are becoming available, and certainly these varieties, utilisation of these varieties is going to hopefully dampen down the incidence and the importance of this disease. Thank you, Bridget. The next tier of that pyramid is moving into that non-chemical farm management, and really what we're talking about there is reducing the exposure of the crop to the disease. So crop rotation, moving your crop away, moving your crop onto stubble of a different disease. Stubble management, if you are in a situation where you need to be going back into a paddock, reducing that stubble in some way if possible. In terms of those biotrophic diseases, managing the green bridge. And certainly things like sowing date. If we've got a barley program, maybe the barley on barley paddocks are the ones that get sown at the end of the program. That can reduce the length of time at which a crop is exposed to disease. Thank you, Bridget. We'll just use net blotch as an example. Spot form and net form are obviously stubble borne diseases. We're all aware of this, but if we can see that barley stubble with cooler, moist conditions, we get the formation of either sexual fruiting bodies or asexual conidia on that stubble. Those conidia are produced with moisture and released, and that moisture obviously creates nice infection conditions as well. Basically, the closer you are to that stubble, the greater bath of spores you're going to get the earlier in the season. The greater reliance there is on fungicide, the greater likelihood that you're going to need multiple fungicide applications to manage disease in that crop. Removing yourself from that inoculum reduces the requirement for fungicide. Thank you, Bridget. And as the top of that pyramid, the final part of the pyramid is fungicides. So that's where you're utilising fungicides to address additional risk, to address those paddocks in which some of those other aspects aren't fully covered. But certainly that fungicides should be the final component of an integrated disease management approach. Thank you, Bridget. And so what are some of the tips around them? And you're all aware of these, but I guess we just need to think about, and this is for this year, I guess, for the rest of this season, from August into September and into October maybe. What are some of the things we need to think about in terms of choosing a fungicide, whether we apply a fungicide? It is a high disease year, but not all crops need fungicide. I guess a question to ask is, will you get a return on investment for that fungicide? If the fungicide isn't going to give you a positive return on investment, then there's really no reason to be applying that fungicide. Is the situation right? Is it a disease? We know that currently there's a lot of physiological, nutritional, water-induced symptoms which won't be responding to a fungicide. What's the growth stage of your crop? All of those questions we need to ask in that limiting applications question. Obviously, alternating or mixing modes of action, including, as Fran's already talked about, using those SDHIs and strobies only once per season. We're trying to reduce the selection pressure applied on the fungicides. And so using regular applications of the same active ingredient is going to obviously increase the selection pressure. Protection, not cure, that makes sense. I'm not talking about spraying a green crop. I'm talking about getting in at the start of an epidemic rather than trying to retrieve a crop that's heavily infected. Staying within label rates, and I think something that is not necessarily a fungicide resistance message this year, but certainly that's something that's very relevant, is the withholding periods for these fungicides in these high disease years with these early sown crops. There's certainly temptation or desire to apply fungicide in situations that are outside the label recommendation in terms of timing. That's not, we need to be aware of that in terms of those limits are applied for marketing and industry reasons as well as other reasons. And if you're in doubt, if the response isn't what you expect, certainly the way to go is to be monitoring those crops, speaking to the CCDM and getting samples tested. Thank you, Bridget. So take-home messages, split these up into this year and next year. I think one that I haven't got on there is that, as I said, Fran's maps have certainly indicated that fungicide resistance is an issue for all of us, not just the high rainfall growers, not just the South Coast, but certainly an issue that all growers need to be aware of. Disease risk this year, it's going to be high in some crops. Make sure you understand whether or not you're going to get a response to that fungicide. And really, we need to be abiding by those fungicide resistance guidelines when choosing and applying the fungicides. If we're not getting the response we're expecting, understanding that we've applied the fungicide as it should be applied, certainly be contacting the CCDM and Fran to talk about the resistance issues. And this season, I think, if anything, this season and the information Fran's talked about has certainly shown us that we need to be thinking about resistance. We need to be thinking about the fact that diseases are an important component of our cropping threats, and we need to be thinking about planning to utilise all aspects of IDM to reduce that reliance on fungicides coming into next season. So thinking about rotating out of some of those continuous species paddocks, thinking about ways in which we can alter our variety, change our variety, try one of these newer, slightly more resistant spot form varieties. So certainly keeping all those IDM matters at front of mind for coming into 2022. Thanks, Bridget.
Excellent. Thank you very much for that, Geoff, and apologies again for all the technical glitches, but I think we've just about got there. So yeah, just a reminder again of who AFREN is. The experts in this project really are some of the best in the country, so make sure to visit the AFREN website to read all the resources that we have available. Contact details here, and a recording of this webinar will go up on the website. But just wondering, a question that's come in, and I might direct this to you, Geoff, I think is around, is fungicide resistance a regional issue, or is it something that, I mean, you sort of touched on it, but is it something that needs to be managed at a regional level, or you know, how widespread are some of these issues?
Well, I'll let Fran continue on, but I will make a point that I guess my broader point is that we find these incidences of fungicide resistance in various locations, and either we will see a spread of resistance. I mean, if in terms of that spot form net blotch, for example, I showed you those spores. Those spores are airborne. They will move between paddocks, so that resistant pathotype or isolate will radiate away from that initial incidence. But then we do get independent selection events occurring in different locations. So from my point of view, it is a bit of both. There is a spread from a foci, but also there will be independent occurrences of resistance. But I'll let Fran clarify a bit further on what I'm talking about.
Yeah, thanks, Geoff. Well, probably first to clarify that I'm not the leader of the Center for Crop and Disease Management, as I was introduced. I think that I oversight that. Certainly, I'm not paid at that level. So I lead the Fungicide Resistance Group. So we do work on fungicide resistance analysis within the Center for Crop and Disease Management. So I think that this is a very interesting question and quite important for the industry. So yeah, so I agree with Geoff's comments. So we've got, obviously, resistance is detected somewhere, and then, it can spread to other areas. Resistance can also emerge independently, right? And we have that situation with barley mildew in Western Australia in past years, where actually we managed to detect up to 20 different independent emergences of the resistance in Western Australia. Now, detecting resistance in a region doesn't mean that basically, that compound that is affected cannot be used in the entire state anymore, okay? So that happens, that situation, we will potentially get to that situation with some compounds, but that only will happen when the resistance is basically the dominant part of the population. With SDHIs at the moment, is not the dominant part of the population, fortunately. So that means that we still have plenty of room for SDHIs, but we have to use them with a lot of common sense. If we start, just abusing those compounds, they're going to have a very short stint in the control of diseases in Western Australia, unfortunately. And we don't want that. We don't want to see that. We want to be able to have a very healthy system where we have plenty of different mode of actions that we can keep rotating so they can maintain the lifespan, the different chemicals. Because Geoff was showing very interesting slides about genetics resistance. Breeding a variety with sufficient level of resistance to certain diseases is not an easy task, right? So if we abuse them, they're gone, right? And it takes a number of years in order for a new variety to be, delivering to the market again. So we have to make sure that we combine, the rational use of resistance, genetic resistance, and the rational use of fungicides together so that we get the best out of both, okay?
Great, thank you. We've just had another question come through, and obviously it's been quite wet in WA this year. The question is, does waterlogging resulting in stress plants affect fungal resistance, or only indirectly by requiring more applications of fungicide? Geoff?
So the answer to your question, the direct answer is I'm not sure. But what we do know is depending on the disease involved. For example, if we're talking about spot form net blotch, we know that plants that are stressed nutritionally will have a greater impact of disease, not necessarily more disease, but a greater impact on that disease on, for example, leaf loss. So the combined impact of disease plus a nutritional issue will result in a greater speed of leaf loss. And I could expect that in a waterlogging sense, a similar thing could happen in that the waterlogging impact on leaf retention or leaf health combined with the impact of a disease will result in a greater impact of those two combined. I guess the question comes back to the question about fungicide application and whether you're going to get a return on investment. The question then comes about the degree of waterlogging, the outlook for that crop, and whether a fungicide applied to that crop is actually going to give you a response, and whether the investment in that crop is worth making. But I mean that's a general answer to something.
Yeah, that kind of leads on to the next question that I had for you, Geoff, around any decision support tools out there to help growers, when they should actually use fungicide. So I just wondered if you could elaborate on that, please.
Yeah, right. So look, there are a couple of DPIRD, particularly DPIRD through several GRDC funded projects have produced some decision support aids in terms of particularly the ones that are available at this time, centre on canola, so the blackleg CM, the sclerotinia CM. In wheat, there is the stripe rust WM and yellow spot WM. So they are decision support tools which help with the understanding the likelihood of getting an economic response to an application of fungicide under a certain disease pressure and at a certain growth stage and with the environmental conditions that might be happening after that application. And certainly there is work being done in terms of things like barley net blotch. So yes, there are tools available, and there will continue to become tools available.